Okay, Wildcats. Today we're looking at Monday, January 14th, quadratic formula and complex roots on page 42. If you would, update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. Now, we're looking at the quadratic formula and discriminant on page 42. First, let's write the quadratic function f of x equals ax squared plus bx plus c. And we're going to use that form later when we get to the quadratic formula. All right, to solve a quadratic function, the function is set equal to 0. The solution to a quadratic function are x-intercepts, also called the roots and or zeros. There are three types of solutions to a quadratic function. One, when it crosses the x-axis twice, there's two real solutions. Two, when it touches the x-axis once, there's one real solution. And three, when it doesn't touch the x-axis at all, so that's no real solutions or a complex number or imaginary solution. All right, there are three algebraic ways to solve a quadratic function. 1, factoring. 2, completing the square. 3, quadratic formula, where d is equal to the discriminant, which is b squared minus 4 times ac. When d is greater than 0, there's two real solutions. When d equals 0, there's one real solution. When d is less than 0, there's no real solutions. And here we have the quadratic formula. Notice the b, the a, and the c. Well, we get that from the quadratic function where this is a, b, and c. All right, there are two ways to check the solutions. 1, graph. 2, using a table. If you would, finish up your notes. All right, now your notes are updated. Let's look at our examples. Now, I've added some lines to keep the work organized. You can do so. You don't have to, but it might help keep your work a little bit more organized. All right, example 1. Find the zeros of each function using the quadratic formula. So the first thing you do is if there's not a number in front of x, put a 1. Then you identify the a, b, and c. And let me do some camera adjusting here. All right, so now a is 1, b is 10, and c is -2. Okay, once you have that, then we're going to use the quadratic formula, which you might write here at the top of the page so you don't have to keep looking at your notes. So the quadratic formula is x equals -b plus or minus the square root of b squared minus 4 times ac all divided by 2a. All right, so with that, we have x equals -b, so that's -10 plus or minus the square root of 10 squared minus 4 times a, which is 1, times c, which is -2, all divided by 2 times 1. So we start to simplify. X equals -10 plus or minus the square root of 10 squared is 100 plus 4 times 2 is 8, which is 108. 2 times 1 is 2. So then x equals -10 plus or minus. Now we need to see if we can find a perfect square that will divide into 108 to simplify. So to do that, what we're going to do in our calculator is I'm going to go to New Document, No, Add Graph. I'm going to take 108 divided by X, press Enter. Don't care about the graph. Control T, looking at the table. So the first perfect square is 4, and you can see here that 108 divided by 4 is 27. So we can write 108 as a product of 4 times 27 by 2. Now, why that's significant is because now we can take the square root of 4 times the square root of 27. So we have x equals negative 10 plus or minus the square root of 4 times the square root of 27 divided by 2. Well, the square root of 4 is 2. So we have x equals, well, negative 10 divided by 2 is 5. So it's negative 5 plus or minus. The square root of 4 is 2. 2 divided by 2 is 1. So this is 1 times the square root of 27. So now we can put that in the calculator and get the decimal. So x equals on New Document, No, Add Calculator. So negative 5 plus control square root of 27. And let's just go to 2 decimal places, or actually, yeah. So the 6 rounds a 9 up to 10, which rounds it up to 2. So this is 0.20. Now don't forget though, we need to do the minus. So I'm going to highlight, press enter, change the plus to a minus, and now we get negative 10.20. All right, so now let's take a look at example 2. All right, so the first step is we identify the A, B, and C. So, and also put a 1 in front of the X. So A is 2, B is 1, C is negative 10. Now we apply those numbers to the quadratic formula. So X equals negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 10 divided by 2 times 2. Now, I almost forgot to look at the discriminant on example 1, which we can come back to, but let's look at it in example 2. So the discriminant is basically this piece right here. So 1 squared minus 4 times 2 times negative 10. Well, that's 1 plus 4 times 2 is 8 times 10 is 80 plus 1, so 81. So since discriminant is 81, we know that that value is greater than 0. So we can say that there are 2 real solutions. Okay, so now let's apply these numbers and find the two real solutions. So x equals -1 plus or minus, well, we know that this is the square root of 81 divided by 4. Okay, so then that's x equals -1 plus or minus the square root of 81 is 9 divided by 4. So that's x equals -1 plus 9 divided by 4, which is -1 plus 9 is 8. 8 divided by 4 is 2. So one of the solutions is x equals 2. Now we have x equals -1 minus 9 divided by 4, which is -10 divided by 4, which reduces to be -5 divided by 2. So x equals -5 divided by 2. All right, so let's come back to example 1, and let's look at the discriminant. Now, we should, in doing the discriminant, get a value greater than 0 because we got two real solutions. If we didn't, then we made a mistake somewhere in our work, okay? So our discriminant, we know, is 10 squared minus 4 times 1 times -2, which we know is 108, which we know is greater than 0. So we know that there are two real solutions. All right, so now let's take a look at example 3. All right, first thing, put a 1 in front of the x squared. So a equals 1, b equals -6, c. Now wait a second. Notice that the -9 is on the right side. Well, you can't do the quadratic formula with the a, b, and c value unless all the values are on the left or right side. So what we need to do is add 9 to both sides. So that becomes 0, and our c value becomes 9. Now, we want to look at the discriminant. So d equals, now when b is a negative, you need to put it in parentheses in your calculator. So -6 squared minus 4 times 1 times 9. So that's equal to positive 36 minus 36. So the discriminant equals 0. Now, when the discriminant equals 0, we know from our notes that it's one real solution. Okay, so now we apply these values to the quadratic formula. So x equals -6 plus or minus the square root of, now you have to put a negative number in parentheses when you square it. So negative 6 squared minus 4 times 1 times 9 so x equals a negative times a negative is positive, so that's positive 6 plus or minus the square root of, well, we already found the discriminant, which is 0, divided by 2. So then that's x equals 6 plus or minus 0 divided by 2. So now we have x equals 6 plus 0 divided by 2, which equals 3. So x equals 3. And then x equals 6 minus 0 divided by 2, which equals 3. So x equals 3 again. Notice we knew that we were going to get one real solution, but when you get the same number twice, we say that x equals 3, and we have to say multiplicity of 2. All right, so let's look at example 4. So first thing, put a 1 in front of the x, so we know it's negative 1. So then a is 2, b is negative 1, c is 2. So now we apply the discriminant. So d equals, so I think I drew this black line a little too far down. All right. So d equals negative 1 squared. And remember, whenever you're squaring a negative number, you have to put it in parentheses in your calculator. Minus 4 times 2 times 2. So d equals 1 minus 4 times 2 is 8, 8 times 2 is 16. So 1 minus 16 is negative 15, which is less than 0. So we know when the discriminant is less than 0, then we have no real solutions. Okay, so now let's apply that to example 4. So x equals negative 1 plus or minus the square root of negative 1 squared minus 4 times 2 times 2 divided by 2 times 2. Okay, so x equals negative times negative is positive. It's 1 plus or minus the square root of negative 15 divided by 4 . Now we want to see if there's a perfect root that goes into 15. So I'm going to use my calculator. I'm going to go to on, new document, no, add graph, 15 divided by x, enter, control T. So the first one is 4. That's a first square root or a perfect root. That doesn't work. Next one is 9. That doesn't work. And 16 is past the number, so we know that There's no perfect square that's going to divide evenly into 15. So we know that we can leave that the way it is. Now, the square root of a negative number is an imaginary number. So we have x equals 1 plus or minus the square root of 15i divided by 4. So your two answers are x equals 1 plus the square root of 15i divided by 4, and x equals 1 minus the square root of 15i divided by 4. All right, so if you would finish up your examples and start working on the assignment, and have a wonderful Wildcat day.